which is consistent with my free body diagram, mg sine theta minus the friction equal to ma. Then we go to the equation for torque, and we said that the only force creating torque is the friction, so it will be only frictional torque. But we need to know the direction of that torque, and for that I said that we apply the right-hand rule. In which direction is moving the object? This way, which is clockwise or counterclockwise? Clockwise. So any force that creates torque clockwise, clockwise means that my thumb have to be into the board, will be a positive torque. So if I have any force creating torque like this, will be a positive torque. If you go to the friction, right-hand rule, you put the hands in the direction of R, and then you turn your fingers in the direction of F. In which direction is the friction? Is positive or negative? Positive. So since it's positive, my torque, according to this definition, will be R of the object times the friction equal to I alpha. So, in order to operate here, I need to move this R to here. So, what I will do now is just, I cannot operate yet, so mg sine theta minus friction equal to ma. Now, I will divide by R both sides, because I want to leave friction to eliminate alone. But what is alpha in terms of A? A over R. So this is very important to replace, because otherwise you will have three unknowns. We want to have two unknowns because we have two equations. So I will come here and I will say I alpha, but what is I? Let's assume that this is a disk. If I said that it's a disk, what will be I? mr squared, 1/2 mr squared. 1/2 mr squared times alpha, which you told me that is A over R. From where? A over R is alpha. So I come here, I said A over R. And now, beside that, there was R before here. You remember? Which I brought to here. I divide by R both sides. So I will have here R squared. And what happened to R squared and R squared here? They cancel out. So now I can manipulate my equation. I can add both equations. And what happened to negative F and F? They cancel out. And now, when I add it, I will have mg sine theta here equal to m of the center of mass plus 1/2 mr squared. Sorry, A. And what happened to the mass if it's in every element? N. I can factor out this m, and m cancels out with m. So what I will get, g sine theta equal 1 plus 1/2, how much will be? 3/2 times A. In the case that the disk is moving, what will be A? 2/3 g sine theta. When the object was sliding without friction, what was the acceleration due to gravity? We did a lot based on that. When the object was sliding without friction, what is the only force acting along X? Let's assume that this object is sliding without friction. What is the only force acting here? G sine theta, or mg sine theta. Mg sine theta is equal to ma. Mass cancels out. What will be the acceleration due to gravity? G sine theta. So if an object is sliding without friction, will be G sine theta. Which one is greater? An object sliding without friction on ice, or an object rotating? What is greater? 1 or 2/3? 1. So if the object doesn't have friction and the object doesn't have rotation, is 1/3 greater than this one. So what is the meaning? That when a disk is rotating, due to the rotation, 1/3 of the acceleration is lost into the rotation. So if this was sliding without friction, will be G sine theta. But if it's rotating with a static friction,